Hi everyone, my name is Emma, and this video is about wildfires and combustion. So I'm going to be showing some math and observations and using some materials from class. So let's get started. If you can believe it, the number of fires per year in California has actually been decreasing. I know it doesn't seem like it because these fires have been affecting everyone a lot more in recent years, and that's just because they're more destructive now. So as you can see in this graph, the size of the wildfires are increasing. So even if there are less annually, they're still getting more destructive and taking up more resources. This is in large part due to global warming. A quote from National Geographic says that increasing heat, changing rain and snow patterns, shift in plant communities, and other climate-related changes have vastly increased the likelihood that fires will start more often and burn more intensely and widely than they have in the past. This quote basically reads that due to global warming, the climate in California has become drier, and we see droughts, less rainfall, and less diverse weather patterns and plant patterns, meaning there's more fuel to burn and larger, more destructive fires are occurring. So even though there are more destructive fires nowadays, that's not to say that there aren't benefits. However, these benefits are less to humans and more to the environment. Wildfires occur naturally in nature for many reasons, and they're beneficial because they can clear debris and break down nutrients and minerals in the burning plants and debris. This makes for more fertile land and makes it easier for plants to grow again. As most things are, where there's pros, there are cons. Some of these cons affect the environment, as in they can destroy ecosystems, but most affect humans by taking over houses and people's land and property and causing negative health effects. Now that we know the why of wildfires, what about the how? Well, fire is actually a result of combustion. So what is combustion? Combustion is a reaction caused when the bonds in a molecule break. In these bonds is stored potential energy, and when broken, they release kinetic energy and light energy. This results in a flame. The heat in the flame being increased kinetic energy and its visual being light energy. What's also happening in the flame is the atoms are rearranging into new molecules. These atoms rearranging support the concept of conservation of mass. So let's look at this with an example. Okay, we'll use methane gas and see what happens when it goes through combustion. So when it goes through combustion, its molecules rearrange and make new bonds with the same atoms. So as we can see here, methane has 1 carbon atom, 4 hydrogen atoms, and 4 oxygen atoms. On the other side, where the product is, there are also 1 carbon atom, 4 hydrogen atoms, and 4 oxygen atoms, even if they've been rearranged. So there's still the same number of atoms, even if they're rearranged into new molecules, and that is conservation of mass. Now that we understand combustion, let's see how we can use it to quantify wildfires. To do this, we're going to measure the combustion of the average California pine tree, also known as how much heat is released when it's on fire. So for this, we use the Q is my cat equation, that's an easy way to remember it, and we're looking for joules. So all that we have to do is fill in our different variables, and as you can see, these are them. And once we've done that, all you have to do is stick them into your equation. Once that's done, all you have to do is multiply your variables together to get your answer. So, as we can see, there are 10,802,071.7 joules of heat released during the combustion of the average California pine tree. All the information we've gone over in this video, we can finally summarize it into some observations about wildfire. So we'll start with qualitative observations. First, as we know, fire is very destructive. Sometimes in a good way though. Fire is hot, as we know from seeing the kinetic energy increase in its atoms and molecules. We know that it needs fuel to burn, and from the fire triangle, we know that it requires oxygen. Now on to quantitative observations. So as we know from measuring the joules in the average pine tree, we could measure just about anything that releases heat in a wildfire as long as we use the Q is my cat equation. So that is already so many observations we could make. Next, we know that wildfire has many fuel sources, not just one, because it burns a whole landscape, unlike candles and other things that have one fuel source. We also know from our conservation of mass equation how many atoms and molecules are transferred during combustion. So we could also measure this using so many different fuel sources and finding out so many more things. Thank you so much for watching my video. I hope it was helpful and that you enjoyed it. Let me know if you have any questions. Okay, bye!